Hello, it's that time again. Another tap math video from Math 6. And I am DJ Tay. All right, so welcome, Mrs. Traster's classes. We are excited to have you here. We're going to be doing the Unit 2 study guide on rate, ratio, and proportional reasoning. But we always have to do some cool game codes, right? So for this video, you'll need your Unit 2 study guide. Unit 2 study guide. It looks like this. You received this on Friday. And you'll also need a sheet of notebook paper with your name, date, and class period on it. And I want you to write on there my math dinosaur name. And then codes 1, 2, and 3, because we're going to go and collect codes throughout this video. And then you're going to write at the end what your math dinosaur name is based on those codes. So let's get started. As usual, I am going to put my name, date, and class period on my study guide. And class period, let's see, who am I going to give a shout out to today? I've given a shout out to fifth period and first period before. I'm going to give a shout out to, I'm going to give a shout out to my second period today. Go second period. All right, so let's look at these problems. Let's look at the first one. I'm going to go through a few of them and then give you the first code. Let's just adjust the camera just a little bit. Okay, so the first one says an aircraft has a total of 200 seats. Only 50 seats were occupied during a certain flight. What was the ratio of the number of seats that were occupied to the number of seats that were not occupied during the flight? Be sure to simplify your answer. Okay, so an aircraft has a total of 200 seats, but only 50 seats were occupied. So they want to know the ratio of seats that were occupied to the number of seats that were not occupied. So I know how many were occupied. It tells me 50 seats. So now I have to find out the amount that were not occupied. The amount of seats that weren't occupied is the 200 seats minus the 50 that were occupied gives me 150 of them. So my ratio of seats that were occupied to the ones that were not is 50 to 150. But this says be sure to simplify my answer. So I am going to have to reduce or simplify this ratio by finding the greatest common factor. The greatest common factor between 50 and 150 would be 50. How many 50s do I get out of 50? Just one. How many 50s out of 150? I get 3. So my simplified ratio is 1 to 3. All right, number 2. If the ratio of boys to girls in the 6th grade chorus is 3 to 5, which choice shows possible numbers of the boys and girls in the chorus? So I have choices, but I have to make sure that my ratio remains 3 to 5. So that means whichever combination that I have here, it must reduce or simplify down to 3 to 5. So I'm going to look for the common factors of each of these and write what they reduce down to so that I can find a match. So 18 boys and 35 girls. Do they have a common factor? 18 and 35. Nope, no common factors. B says 15 boys and 25 girls. So 15 and 25, they have a common factor of 5. So how many 5s go into 15? 3. And how many 5s go into 25? 5. So I believe I found a match, but I'm going to keep going just to reduce all of these and see what we have here. So 25 boys and 15 girls. The common factor between 25 and 15 is 5. So I'm going to reduce this by 5. How many 5s out of 25? I get 5. How many 5s out of 15? I get 3. Now I'm going to go to my next one. 35 boys and 18 girls. Well, I don't have a common factor between 18 and 35. So it's nothing to do there. But I have to remember it says boys to girls. That's the order, 3, 2, 5. And that would be my answer B. All right. Number 3 says, in a small group of ducks, there are 8 males and 3 females. Which ratio of males to females is an equivalent ratio? All right, so if it's an equivalent ratio, that means that I take my 8 to 3, and I have to, whatever I multiply my 8 by, I use that same number to multiply my 3 by. So, all right, so let's look. At the first one is 16 to 9. So if I'm looking at 16 and comparing it to 8, that 8 to 16 means the 8 was multiplied twice. And 3 to 9 means the 3 was multiplied 3 times. One was multiplied 2 times, one was multiplied by 3. Those are not a match. So I know my answer is not A. Let's look at B. B is 4 to 3. All right, so 8 goes to 4 by dividing by 2. 3 goes to 3 by dividing by 1. So that's not a match. Let's look at C. 8 goes to 6. 3 goes to 16. Nah, that's definitely not a match. Let's look at this one. 8 to 24. We go from 8 males to 24 males by multiplying by 3. We go from 3 females to 9 female ducks by multiplying by 3. Hey, these are both multiplying by 3. I found a match. Number 4. At last Saturday's ball game, the concession stand sold 20 hot dogs, 40 hamburgers, and 200 soft drinks. What was the ratio of hot dogs and hamburgers sold to the number of soft drinks sold? So this one can be tricky. So I know that and tells me that I have to combine my hot dogs and hamburgers. So hot dogs is 20 and my hamburgers, that's 40. So my 20 plus 40 equals 60. So it wants to know the ratio of hot dogs and hamburgers, which I now know is 60, to the number of soft drinks sold. 60 to 200. 200 soft drinks sold. Okay, but that's not as simplified as it could be. So if I had 60 to 200, if I find the greatest common factor between these two, I could reduce or simplify this ratio even further. 60 and 200, they both share a factor of 20. So if I use a factor of 20, that means I'm dividing my numerator by 20. 60 divided by 20 is 3. And I'm dividing my denominator by 20. 200 divided by 20 is 10. So my ratio of hot dogs and hamburgers sold to the number of soft drinks sold is 3 to 10. All right, number 5. Miss Cobb divided a bag of 32 chocolate candies between Bob and Patrick. Bob received 5 pieces of candy for every 3 pieces that Patrick received. How many total candies did each student receive? This sounds like a really, really good problem for our tape diagram strategy. Really great problem for that. So I'm going to write Bob and I'm going to write Patrick. And I know that Bob received 5 pieces and Patrick received 3. So that means for Bob, I'm going to draw 5 boxes. And remember, they don't have to be pretty. And for Patrick, I'm only going to draw 3. Okay, so with Bob receiving 5 at a time and 3 for Patrick, they have to total only 32 pieces. So that means in these 1, 2, 3, 4, 5, 6, 7, 8 boxes, they have to total 32. So I have to split this 32 up amongst 8 boxes. 32 divided by 8 is 4. So that means I'm going to put 4 in every single one of these boxes. So now I can see how many pieces they each get. Bob received 4 plus 4 plus 4 plus 4 plus 4 for a total of 20 candies. And Patrick received 4 plus 4 plus 4 for a total of 12 candies. And look at that. We know that 20 plus 12 equals 32. Okay, number 6. A class of 25 students share 125 markers. Which statement is true? So we have a few options. For every 5 students, there's 1 marker. For every 5 students, there are 6 markers. For every 1 student, there are 25 markers. For every 1 student, there are 5 markers. So what this is basically asking us to do is to find which one of these answer choices will give us a reduced ratio from 25 to 125. So if I reduce this ratio, I have 25 students over 125 markers. And I'm going to find the greatest common factor and reduce this down or simplify it. The greatest common factor between 25 and 125 is 25. How many 25s do I get out of 25? I get 1. And remember, if we're comparing students in a numerator, we're comparing students in the numerator over here. And at the bottom, we're comparing markers, so we're comparing markers in the denominator over here. So we know that 25 goes into 25 one time, but how many times does 25 go into 125? It goes into 125 5 times. So I know that 1 student is going to receive 5 markers. And there's my answer, D. Okay, so we are done with the first page. So that means you're going to now get your first code. All right, so for the first code, you are going to take first code, the first letter of your last name. First letter of your last name. So if it's A or Y, it's chrono. C or X, mega. E or V, chump. G or T, dino. I or R, spike. K or P, bite. M, Bronto. If it's B or Z, Terra. D or W, Spino. F or U, Dragon. H or S, Rock. J or Q, try, L or O, horn, and N, tighten. So my last name is Pugh. So remember that page I told you to get out to make for your codes to collect them? All right, so my first one for code 1 is Pugh. So mine is going to be bite. So my first code is bite. All right, my code 1 is bite. All right, let's go back to our packet. Number 7. Which scenario has a unit rate of 12 laps per hour? 12 laps per hour. So remember that per is saying for each or for one. So that means 12 laps to 1 hour. All right. So we are going to see if each of these reduce to 12 laps to 1 hour, 12 to 1 ratio. All right. So let's look at the first one. Mario runs 2 laps in 24 hours. Well, this is going to reduce to, how many 2s do I get out of 2? 1. How many 2s out of 24? 12. And remember, we're looking at a 12 to 1 ratio we're trying to find, right? So let's look at the next one. Mario runs 60 laps in 4 hours. The greatest common factor between 4 and 60 is 4. How many 4s do I get out of 60? I get 15 of them. How many 4s out of 4? I get 1. Let's look at Mario runs 24 laps in 2 hours. So let's look. The common factor between 24 and 2 is 2. How many 2s out of 24? I get 12. How many 2s out of 2? I get 1. All right, and let's look at the last one. Mario runs 144 laps in 12 hours. 12 and 144 has a greatest common factor of 12. So how many 12s in 144? 12. How many 12s in 12? Just 1. So your answer could be B or D. Number 8. Jordan's cookie recipe calls for 2 teaspoons of vanilla for every 8 teaspoons of sugar. What is the unit rate in terms of sugar to vanilla? So my first job is to make sure that I'm writing my ratio correctly. So it's asking me for sugar, which is 8, to vanilla, which is 2. So I'm going to put an S for sugar and a V for vanilla. All right. So we have an 8 to 2 ratio. But it's asking us, they want the unit rate, which means that they want to know the 1 of something. So they want to know, it says from sugar to vanilla. So for 1 vanilla, they want to know how many sugars. Well, I know if I'm going from 1 to 2, I'm multiplying by 2. So whatever this number is, if I multiply it by 2, I get 8, and that's 4. So my ratio for my unit rate in terms of sugar to vanilla is 4 to 1. Okay, let's look at the next one. The table shows how much money a grocery store receives for selling different amounts of asparagus. If the unit rate is constant, what are the total sales for 10 pounds of asparagus? Okay, so I see this chart here. I see that 4 pounds cost $6, 6 pounds cost $9, 8 pounds cost $12. So I need to know how much 10 pounds of asparagus would cost. So in order to find that out, I need to know how much does 1 cost. That's why they ask if the unit rate is constant. That means that if we find the price of 1 pound and then see what our 10 pounds will cost. So I am going to have to find that unit rate. So I'm going to set up. I know that $6 is for the price of 4 pounds. And why am I putting pounds on the bottom in the denominator? Because I want to find the price of 1 pound. And remember, the 1 in unit rate goes into the denominator. So I have to match and compare pounds to pounds and dollars to dollars. So I have to look at the jump that I can make, the relationship here. So I'm going from 4 to 1. In order to do that, I have to go in from 4 to 1 pound. I'm dividing by 4. So that means in my numerator, I have to take that $6 and divide it by 4. You can pop this into your calculator really quickly, and it gives you 1.5, which means in money, it's $1.50. So that means that it's $1.50 for 1 pound. So if I want to know the price of 10 pounds, I'm going to take that $1.50 and times that by 10 pounds. And I get that the price of 10 pounds is $15. All right, let's look at the next one. Look at the graph. Which statement is true about the relationship on the graph? This one printed it a little weirdly. So in class, I gave you the points. This first point was 1, 12. The next point was 2, 24. And the last point was 3, 36. So we see that the number of ink cartridges, if you buy 1, 2, or 3, and we see the price. So if you buy 1, it costs $12, 2, $24, 3, $36. So it's asking us to look at that and compare the relationship. It says for every ink cartridge, the cost increases by $4. Let's see, do they increase by $4? $12 going up to $24. That's not $4. What is that? That's $12. So for every ink cartridge, the cost increases by $12 is what I'm thinking it is. But let's make sure we eliminate these other answers, because we know A is not it. C says for every ink cartridge, the cost decreases by $4. Well, we know that that's not true. It says for every ink cartridge, the cost decreases by $12. Well, as I am adding on my ink cartridges, the price is not decreasing, it's increasing. So I know for every ink cartridge, the cost increased by $12. All right, number 11. A recipe for punch calls for 1 cup of sugar for every 6 cups of water. Which ordered pair would not be on a graph that describes this situation? So just like we saw here, we had a graph of our 1 to our 12, our 2 to our 24, our 3 to our 36. That's how we would look at these in a table, a ratio table. So they are telling us that for sugar and for water, one cup of sugar to 6 cups of water. See that? All right, so we are going to see which one of these makes sense. So we know our original is 1 to 6, and they want to know which one would not be on the graph. So that means it can't match that 1 to 6 ratio. So we know that 1 to 6 matches 1 to 6. So that can't be correct. Let's go ahead and put in our next one. 2 to 30. And then we have 3 to 18 and 4 to 24. So if I'm making a jump from 1 to 6, from 1 to 4, I'm multiplying by 4. 6 times 4 is 24. Awesome. So I know that my 4 to 24, that one works as well. So it doesn't fit the knot. All right, when I go from 1 to 3, 1 times 3 gives me 3. And so I have to multiply my 6 by 3 as well. And 6 times 3 is 18. So that's a match as well. That will be on my graph. So what do I have left? 2, 30. Because when I go from 1 to 2, that's being multiplied by 2. So that means I should also multiply my 6 by 2. But they gave me 30. That's not a multiple. That's not 6 times 2. So my answer is C. 2, 30 would not be on that graph for a 1 to 6 ratio of sugar to water. All right, so it's time for the next code. It's time for the next code. So your second code is going to be your math teacher. So code number 2, your math teacher in class period. So if you have Mrs. Pugh, that's me. You have DJ Tay. You have, if you're period 1, you're percent. Period 2, angle. Period 3, factor. Period 4, equation. Period 5, pentagon. All right. And I told you guys that I was going to be representing period 2, whoop, whoop, today for DJ Tay's class. So that means that I am angle. So my second code will be angle. All right. So let's look at the codes for Mrs. Traster's class. If you have Mrs. Traster in first period, your code is integer. Second, ratio. Third period, variable. Fourth period, exponent. Fifth period, polygon. All right, awesome. Let's continue our packet. Number 12, the ratio of x to y is 3 to 4. Which table shows the ratio of x to y? So what I am looking for is I'm going to look at each of these tables and see if they reduce to a ratio of 3 to 4. If they do, if each one does reduce or simplify to 3 to 4, then I know that that is the right table they're asking me for. So let's look at the first one. 3 to 4. So that means whatever this simplifies to is going to be 3 to 4. What's a common factor between 6 and 8? It's 2. How many 2's do I get out of 8? I get 4. How many 2's do I get out of 6? I get 3. Is that a 3 to 4 ratio? No, it's a 4 to 3. So I don't need to use A. Let's go to my next one. All right, so remember I'm looking for a 3 to 4. So 8 and 12, what do they have in common, a common factor? They both share a 4. How many 4's go into 8? 2 of them. How many 4's into 12? 3 of them. Is that a 3 to 4 ratio? No. So B is not it. Let's look at C. Again, remember 3 to 4. So I have 9 and 12. A common factor between 9 and 12 is 3. So how many 3's do I get out of 9? I get 3 of them. How many 3's do I get out of 12? I get 4 of them. Hey, cool. I see a 3 to 4. Let me just check my last one just to make sure. 3 to 4 ratio. How many between 3 and 12? They share a 3. How many 3's out of 3? Just 1. How many 3's out of 12? I get 4 of them. This is not a 3 to 4 ratio. So the one that has a 3 to 4 ratio is C. Number 13. The average car on the highway can go 350 miles in 7 hours. At this rate, how long would it take the average car to drive 1,000 miles? So for this one can be done 2 different ways. You can first find the unit rate and then calculate to see, do a ratio proportion to see how many hours you it would take to drive 1,000 miles. Or we can do a quick proportion and solve it using cross multiplication. So I'm going to show you the first way for doing unit rate. It says 350 miles to 7 hours. And it wants to know how long would it take? So how many hours would it take to drive 1,000 miles? So I need to find out how many miles can I drive in just 1 hour. So I'm setting up my proportion of 350 to 7 is equal to my 1, because I want to find out how many miles can I drive in an hour. All right. So I'm going from 7 down to 1 by dividing by 7. So that means I am going to, in my numerator, also divide by 7. And my 350 divided by 7, pop that into your calculators, people. That should give you 50. So that means I'm going 50 miles to 1 hour. So now that I know I'm going 50 miles to 1 hour, I'm going to set that equal to of wanting to go 1,000 miles and try to figure out how many hours. So this is where I'm going to say, all right, I'm making a jump from 50 to 1,000 by multiplying by 20. So that means that I need to multiply my denominator also by 20. So I know that I can drive 1,000 miles in 20 hours. Okay? Let's look at this in another way with cross multiplication. So I could set up my proportion 350 miles in 7 hours and set that equal to 1,000 miles in how many hours? We don't know. So we're going to cross multiply. I don't have a number, 2 numbers here, so I can't use that side. So I'm going to multiply this. 7 times 1,000 equals 7,000. And then I divide it by the number that's left. Divided by 350. If you pop that into your calculator, you get 20. So this was a quicker way of getting that your answer is 20 hours. Number 14. Cannon Grocery charges $6.80 for 10 sodas. Tay's Market charges $7.44 for 12 sodas. Which store has the best unit price on soda and by how much? So I see the price for the cans for each store. They're asking for the unit price. That means if I know the price for 10 cans of soda at Cannon Grocery, I need to find the price of 1 can. And if I know the price for 12 cans of soda at Tay's Market, I need to find the price for just 1 of those cans. And then see